Howdy guys, welcome to another Algebra 2 video. We're going to talk about inverses of exponentials today. If we're trying to solve this equation, we have the fifth power. Remember, the way to get rid of that is to undo that power is to take the fifth root. Okay, here we would take the cube root, where that index, which is the number in this little cradle of the radical, matches that original power of the variable. So this index is 3, this index is 5. Now, the cube root of pi is probably a super nasty number, but it is what it is. What about this guy? If we take the seventh root of both sides, x is going to be equal to the seventh root of the square root of 7. Well, it's kind of weird looking, but that's okay. For any equation y equals x to the b, how would you isolate x in the equation? Well, x is going to be equal to the bth root, where b is your index, of y. What's different about the equations y equals x to the b and y equals b to the x? Well, remember what this one looks like. X to the b is x times x times x times x b times. And this guy is b times b times b times b x times. Can you isolate x in the equation y equals b to the x? What would you do to solve for x, to solve this guy for x? You might think, well, we got to divide by b. So y over b is equal to b to the exponent properties say this is x minus 1. Ooh, kind of run into trouble there, right? So here's where the idea of the inverses of exponentials comes in. We say if b to the y is equal to x, then log base b is how we say this. It goes below the line a little bit, of x on the line equals y. And vice versa. So if you know log base b of x equals y, then you know b to the y is equal to x, okay? So this is known as log form. This is known as exponential form. Okay? Not that we're using a whole lot of calculators right now, but just so you know, calculators use base 10 log. And to convert bases, if you have log base b of x and you want to make that base 10, you could by doing log of x over log of b. Now, it's not such a big deal this year, this little tidbit, because we're not forced into base 10. Desmos is super happy to do whatever base you like it to do. I'll show you how to do that in a little bit. Let's see. Let's solve some of these. So if we're solving for x, x is going to be equal to log base 4 of 259. X is going to be equal to log. So one way to think about this is your base in exponential is a 4 here. Your base of your log has to match that, right? And you know that what you're solving for when you take the log is that variable. So our base is 16. The only other number here is 1/3. X is equal to log, our base for our exponential is 49, so it's going to be the same for our log base 49 of 400. Log base 3 of 10. Log base 25 of 1/4. log base 10. Sorry, I forgot to write x equals. Let me fix that. X equals log base 10. Notice we don't write a base 10 of 1385.46. So when no base is written, it's base 10. It's kind of like, that's the square root of x, even though we don't write that index, right? Okay. What does it mean, though? So what does log base 4 of 259 mean? It's the exponent 4 is raised to in order to equal 259. Okay. And the rest of these guys are going to be practice, okay? So I'm going to pause this for just a second. I'm going to show you how to use a calculator, even though I don't think you're going to need to know how to graph this. So let's talk about this one on Desmos. Give me just a second. I'll open that up and restart the video. Okay, so we've got f of x equals log. Shoot. Instead of doing that, let's hit this little typewriter button under functions, miscellaneous, I think. Yeah, this log base a is what you want if you have a base other than 10. The other one, just the log, that's base 10. So this is going to be any base but 10. So here we want 2 and log base 2 of x. Okay, and you can see what that looks like, kind of. G of x equals 2 to the x. Well, that's pretty. I'm going to drop this. Now, these guys look an awful lot like a reflection. So I'm going to try this just on a whim. Y equals x. Check that out. They're inverses of each other. Notice that base and that base match, right? Okay. So how are these functions related? What are the domain and range of each function? These functions are inverses of one another. And we want the domain of f, the range of f, the domain of g, and the range of g. And we can see from looking at this graph, if you look at the blue, remember the blue is, well, let's look at the red first because it comes first in our list. It's got a vertical asymptote at x equals 0. So it's going to be everything bigger than 0, the domain is, right? And the range is going to be everything. We get to all negative values and all positive values, so negative infinity to infinity. What about for the blue, which is g? The domain is going to be everything. Remember, inverses, domains, and range are exactly swapped. So the range is going to be the same as the domain of f. It's going to be 0 to infinity, exclusive. All right, so this is 0 to infinity because it was a vertical asymptote at x equals 0, which means this guy is 0 to infinity because there's a horizontal asymptote at y equals 0. These are both all reals. And notice that these guys they swap, right? The domain, and that's a characteristic of inverses. Okay, so we skipped a couple of those. Let's just check these out. So what I like to do when we're evaluating these, set it equal to 0. So 2 to the x is equal to 8. Call this the log roll, and one way to do this is to go like this, and then like this. It's almost circular. We call it a roll. Okay, 8 is a power of 2. This is 2 to the third. And so x equals 3. If these bases are the same, then the powers have to be equal. Okay. If this is equal to x, 5 to what power is equal to 1? Well, 1 is the same as 5 to the 0. Okay. Anything but 0 raised to 0 is 1. So x here is 0. And I introduced this x, so technically the answer is just the number, right? Because I made it into an equation so that I could simplify it and solve it. 9 to the x is equal to 3. Ugh. Well, 9 is a power of 3, and that's 9 squared. So 3 to the 2x is equal to 3 to the 1, which means 2x equals 1. So x is 1/2. All right. Convert each log into exponential and vice versa. Okay, so log base 7 of 49 equals 2. 9 to the second equals 81. 10 raised to this power, -1, is equal to 1 over 10. Now, all these statements are true. We're just going from one form to the other. Our base is 10, so I'm not going to write it. Okay. Notice what the log is equal to is always the power, right? So log base 6, the base of my log is the same as the base of my exponential, of 9 is 3x. It doesn't ask us to solve that. If we were asked to, we just divide everything by 3. This is going to be 8. Our base raised to this power is equal to 2x. We could solve that if we needed to. Okay, if you, and we already talked about 22. If you have questions over this, come and see me during office hours and I can help out.